Welcome to today's Java tutorial. In this video, we are going to understand two very important object-oriented programming concepts in Java, encapsulation and abstraction, explained step by step with simple examples. Let's start with encapsulation. Encapsulation means binding data and methods together into a single unit and hiding internal details from the outside world. In Java, we do not allow direct access to important data. Instead, we control how data is accessed or modified. Why do we use encapsulation? Encapsulation helps protect data, improves security, and gives us controlled access. This means users can only do what we allow them to do, and nothing more. A real-life example of encapsulation is an ATM machine. When you use an ATM, you only see options like withdraw, deposit, or check balance. You do not see how the bank server processes your request internally. That internal logic is hidden. This is encapsulation. In Java, encapsulation works by using private variables and public methods. Private variables cannot be accessed directly from outside the class. Public methods act as controlled entry points to read or modify those variables. Let's understand this with an example. We have a student class where the marks variable is private. Since it is private, it cannot be accessed directly. Instead, we use a public method called setMarks to assign a value, and another public method called getMarks to read the value. Now, when we create a student object, we do not change the marks directly. We call the setter method to set the marks and the getter method to retrieve them. This ensures data safety and control. Encapsulation gives us many benefits. It keeps data safe, avoids accidental changes, and makes programs easier to maintain and modify in the future. Now let's move to the next important concept, abstraction. Abstraction means hiding the internal implementation and showing only what is necessary to the user. The user knows what an object does, but not how it does it. A simple real-life example of abstraction is driving a car. You press the accelerator or brake, but you don't need to know how the engine or fuel system works internally. In Java, abstraction can be achieved in two ways: using an abstract class and using an interface. An abstract class can contain abstract methods. These methods do not have a body. They only declare what should be done, not how it should be done. For example, we create an abstract class called shape with an abstract method draw. The shape class does not know how to draw, it only defines that drawing must happen. Now, when a class like circle extends shape, it must provide its own implementation of the draw method. This means circle decides how the drawing is done. When we create a shape reference pointing to a circle object and call draw, the circle's implementation is executed. This is abstraction in action. Next, we have interfaces. An interface provides 100% abstraction. It contains only method declarations, no implementation. For example, an animal interface defines a sound method. The dog class implements this interface and provides its own sound implementation by printing dog barks. Interfaces help achieve loose coupling and make applications more flexible and scalable. Now let's compare abstract classes and interfaces. Abstract classes provide partial abstraction, while interfaces provide full abstraction. Why is abstraction important? It reduces complexity, supports easy upgrades, improves code readability, and makes applications easier to extend. To summarize today's lesson, encapsulation helps protect and control data. Abstraction helps hide complexity and show only essential features. Together, they form the foundation of clean, secure, and professional Java web design. Thank you for watching this Java tutorial. If you found this video helpful, don't forget to like, share, and subscribe. In the next lesson, we'll continue with more exciting Java concepts.